Hello, my name is Vivian and I'm the host for these podcasts which we are recording for our online course. The idea of the podcast is to give a bit more info on interesting topics and to discuss a little bit and find out more about the modules you've been doing in the online trainings. And for that, I'll be inviting different guests as experts to the podcast to talk with me about the topics and share their view on the different renewable energy topics. My background is renewable energy management. That's what I studied in Germany, and I've been working in renewable energies for 10 years already now, with especially a focus on solar PV and off-grid PV systems. I am now working for DGS, the German Solar Energy Society, and Green Solar Academy, a training academy that is based in South Africa. And in both institutions, we focus a lot on training and solar energy. Today with me is Antje as my first guest. She and I work together for Green and DGS. But maybe you want to introduce yourself with a few words.
Okay, yes. My name is Antje Klauss-Vorreiter. I studied environmental engineering and I started to work in my professional life in biomass to energy projects, mainly in Germany and Southeast Asia. 2004, I started to work also with the German Solar Energy Society DGS. And since then, I have been working in solar energy projects. At the beginning also in Southeast Asia, but then also in Latin America. And 10 years ago, I started to work in South Africa. And together with Vivian, we opened the Green Solar Academy.
Okay, thank you. So our topic of today is renewable energy. And I find it is interesting to understand not only renewable energy but also fossil fuels, because everyone is always talking about renewable energy and why renewable energy is good and why we must use it, but to understand why, it's important to know why fossil fuels are so bad. And fossil fuels are actually, I think, important to understand is where they come from and how they developed. Mm-hmm. So fossil fuels are actually plants and plankton and dead animals that used to live 400 to 100 million years ago. That's incredibly long time. And when they died and were like in the oceans, all the rest of those plants and animals sunk to the ground. And then from the pressure of the water on top of it and different layers of stones and gravel and whatever, coal and oil formed. But it took 100 million years for that process to develop. So what was a plant then, or a tree, formed into coal as we know it now. I find that process is incredibly interesting.
What I personally find more interesting is that the whole process lasted, as you just said, millions of years. And it took the humankind only, a little bit more than 100 years to spend more of half of those resources. So we are speaking mainly about oil and gas. And if you see, we started to use oil and gas when the Industrial Revolution started. And that was at the beginning of the last century. And I mean, opinions are different, but I think most of the scientists agree that we already used more than half of the fossil fuels. So that means we have about 100, 150, maybe 200 years more, because everything becomes more efficient, so we can use more, or we can use the resource a bit longer. But it's not endless, and we have to make a plan.
So there's that mismatch between how long it takes to develop new coal and new oil, and compared to how long we take to use everything up, which is incredibly fast. Yeah, definitely. So it's, if you're like very precise, it is renewable energy, because the process still happens today. We have still like plants falling to the bottom of the ocean, but we don't have a million years time to wait until that formed into coal and oil.
Definitely.
So that's why it's not renewable. We have one more energy source, which is a bit different, the nuclear energy. That one, just to give a definition, it is not a fossil fuel because it is not made of plants and plankton, but it's also not renewable because we are using uranium as a resource to do that nuclear process. And when we've used all the uranium, it's also gone. So there's no new uranium that we can produce or anything.
Yes, so that's one point. But again, I have another point. So, I mean, a lot of people say that nuclear power is a very clean source for energy production. However, from my point of view, nuclear power is not a clean way to produce energy. The problem I see with nuclear power is that so far we have no way to treat or final dispose the waste from nuclear power plants. And you have to imagine that, I mean, we started to research in the 1940s on how to use uranium or how to produce nuclear energy. And the first plants were built in the 1950s, so almost 100 years ago. And still we did not find a way how to dispose the waste, and the waste has very strong radioactivities. And it's not only the disposal of the waste, it's also when you see all the accidents which happened in those 70 years. We had Fukushima, we had Chernobyl, and all these accidents and all the radiation which contaminated environments, complete landscapes. From my point of view, this is not a clean energy.
Yeah, it is clean from the physical point of view because there's no emissions from it. It is, the process itself is clean, but then you're left with the waste. So then you have to see what to do with the waste.
Yes.
And that's, I find if you look at the risk that we are posing ourselves to, then it's definitely something we cannot use anymore. Because if anything goes wrong, it goes really, really wrong. And you see in Fukushima that like all that area is really contaminated. Nobody can live there anymore. People had to relocate. It is just not worth the risk, especially seeing that we have so many better options. So yeah, I agree. It is super interesting technology, but it's not, we shouldn't be using it.
And Fukushima, I think everybody knows Fukushima, but Chernobyl, I think if I'm not wrong, is 35 years ago. And still the whole area, nobody can live there. That's not the way to go, from my point of view.
Yeah. Okay. But talking about fossil fuels, nuclear energy does not have the problem with the emissions, but the other fossil fuels have. So it's not only the availability that makes it not a power source forever, but it's also that there are greenhouse gas emissions. Because when you look how we are using fossil fuels, we are burning them to generate the electricity. Yeah. And when you're burning something, the chemical process releases gas in this case, and it is dangerous greenhouse gas.
Yes, yeah, and if you have a look what happens in the world, I mean, it's almost 75%, so almost 3/4 of greenhouse gas emissions come from energy production. And energy production, I mean, most of the people, when they think about energy, they think about electricity. But electricity is only one part. If you see from that 75% of greenhouse gas emission from energy, 1/3 comes from electricity production, 1/3 from the transport sector, and 1/3 from the building sector, and especially heating in the cold countries in the northern hemisphere. This is really a point, and that's something where we have to start to think about what we can do.
Yeah, to put it into context, the greenhouse gases are what heats up the atmosphere. So those gases kind of block the heat on the Earth from escaping to space. So it causes the planet to heat up more and more, and it causes like temperatures to rise worldwide, changing the climate, It's got all kinds of consequences and definitely many negative impacts on the Earth's climate.
And what I think, I mean, coming back to the point that we started to use the fossil fuels at the beginning of the 19th century, of the 20th century, sorry. So the Northern Hemisphere started with the Industrial Revolution. And still, people on the Northern Hemisphere consume more than 50% of the world's energy. And if you see, China is actually coming right next all of the other countries. It consumes about 30% of the world's energy. And the thing is that China made the same mistakes the Europeans did, or the Northern Hemisphere did. And if we would electrify or bring energy to Africa in the same way how we developed Europe, how Asia developed, or China developed, so then we definitely would have a problem.
And you mean like using lots of energy, powering everything from electricity, not considering, do I really need this? Do I need all the power? But just using it all because it's like available endlessly.
It's using it all, but it's also producing electricity based on burning fossil fuels. And especially if you look at China, I mean, so they use a lot of coal. They fuel most of their power plants with coal. They burn coal. And this is, as you said, not super efficient, but also it produces a lot of greenhouse gases again.
Okay. And you're saying, like, your point was that if all the countries that haven't reached the development state of Europe and China yet, if they would do the same and emerge to the same level of energy consumption, fossil fuels would end definitely quicker.
Definitely.
And there wouldn't be enough for all, eh?
That's the point, yeah. I think we need new concepts. So I think we have to think the whole process of electrification totally new.
Good point. And what a lucky coincidence that this is the topic of the podcast. So let's look at alternatives. We are not trying to invent a new concept for world energy production, but we just want to talk a bit about what possibilities do we have now. And renewable energy as a source for energy and especially electricity are definitely an option and definitely part of the plan. So let's do a quick recap. What are renewable energies?
So is this a question to me?
That's a quiz question
Okay.
for you out there and for Antje.
So we have solar energy, which is our core topic, wind energy. We have biomass, and we can use biomass for biofuels or for the production of biogas. Then we have hydropower, as I would guess especially our Ethiopian colleagues know, and geothermal. So I think that's everything. Did I forget
No,
one?
I think that's all.
Okay.
I think that's all. Yeah. Renewable energies. Just very quick, the definition. Renewable refers to the ability of those energies to regenerate. So solar and wind we can't use up. It's like if the sun dies, then we all die long before on Earth. Yes. So the sunlight comes back every morning. Same for wind, because it's a natural phenomenon.
And directly related to the sun.
Yeah, sure, with a different temperature in the air. Biomass is something that we can reproduce very quickly. Trees regrow. Biomass from like manure from animals, for example, we can get every day. Geothermal is also considered as renewable. Geothermal refers to the heat of the planet, because in the core of our planet is very, very hot, and if you drill into the earth, or if there's a volcano or volcano activities, we can use the heat from that. And hydropower, because rivers, they don't stop flowing. So that's the definition of renewable energy. It doesn't end.
I mean, one could also say clean energy or sustainable energy. I think there are quite a lot of words around there, but I think the renewable energy specifies it the best.
Yeah, and I think the clean energy, that like one of the main characteristics is that it's clean, that it doesn't have a negative impact, or let's say generally doesn't have a negative impact on the environment. So there's no need to burn anything. We are not burning sunlight. As you learned in the online course, we are converting sunlight into electricity, and wind energy is also using the kinetic energy from the wind to convert it into energy through a generator. We're not burning anything, we are not producing any emissions. So in that way, it is clean. And other point, there's no risk of any big catastrophes. We can't have like a nuclear catastrophe. We can't have oil spills or anything. I think solar and wind energy are the least harmful ways to produce energy.
And solar, I mean, the best thing, I mean, solar is like the can you say the cleanest energy? You can't, but I would say it, because with the solar module, you directly collect the light of the sun and you convert it into electricity. And this is really like the first process. It's not like biomass first have to grow, then you have to digest it, then you have biogas, and then you produce electricity. So solar is really, yeah, my favorite, I would say.
Mine as well, definitely, because it's so like simple and yeah, nice process. But you looked up a few numbers for us. You brought some statistics on renewable energy worldwide.
Yeah. I had a look. Presently, 11% of the primary energy in the world is produced based on renewable energies. Of course, so the first renewable energy plants, power plants, were hydropower plants. Most of the countries, they have hydropower plants which are older than 100 years or even older. But then biomass came, so there were a very strong movement also at the beginning of the industrialization to use biomass to produce biogas to operate cars. Unfortunately, it was not that successful, but so we should give it a try again. So if you look what we are using the most right now from the renewable point of view, it's still 6% of hydropower, 2% wind, and each 1% solar, biofuels, and other renewable energy sources. So it's still 90%, almost 90% left. But what we know is that it is possible to electrify or to fuel the world based on renewable energies. And some scientists did some studies what could be an intelligent mixture, and they investigated and found out that it's possible to electrify or energize the whole world based on renewables. And I think what is an interesting point, and what we also always discuss with our participants in our trainings, is, I mean, most of the people can imagine the size of the Sahara Desert. And if we would install photovoltaic power plants in the whole desert, then we could generate 18 times more electricity than we need in the world. So I think this is something which one can understand a little bit, because I mean to say that we can have 100% renewables in 2015, so that's very abstract. But if you see the small size of the Sahara, so then I think one could see or feel that it's possible.
Yeah, definitely. I think it's difficult to understand exactly what are the problems. Why are we not using more renewable energy if we know how bad the others are and that the others are not endless?
I think one problems were costs. And there are still, so some of those technologies are still quite new, and costs is still an issue. But if you look the price reduction for photovoltaic systems in the last 20 years, so I don't think that the people could have imagined that this is possible, so that we can produce photovoltaic electricity cheaper than coal-based electricity, actually.
Yeah, definitely. That is a great advancement. And the thing is, one downside of solar energy is definitely that you can't get so much electricity out of a single solar module. So compared to a coal plant, when you put a coal-fired plant somewhere and you get megawatts of electricity from it, and then if you put a solar module or even a whole like utility-sized solar system, you still don't get as much electricity from that because you just need more space, and it's not so, the conversion process is not so efficient. That's a downside, but also an advantage on the other hand, because solar is much more flexible. You can't put a coal-fired plant just somewhere, but a solar panel you can take with you. You can get it like very small ones that you can put in your backpack or in your car, and
like I usually do when I go hiking.
True, yeah. You take your energy with you. So you're like, wherever you need energy, you can use the solar panel. But on the other hand, then of course you have enough to charge your cell phone, but you don't have enough to power your whole village. That's one challenge, but I think the key lies in combination of the energy sources.
Definitely. It's the combination of the energy sources and maybe also storage solutions, but I think the combination, it's definitely a point.
Yeah, there's sun is available everywhere. If you look at those irradiation maps, if you Google irradiation in the world or solar irradiation, you find those colored maps where you see where the most sunlight is available, and there's of course sun all over the world, but in like northern and southern edge of the world, let's say in like Europe, North America, there's not so much sunlight available, in contrast to around the equator, for example, or Ethiopia. If you take that as an example, Ethiopia has very good irradiation values, so there's like lots of sun available.
Yeah, and it's not only the irradiation value. If you remember what we learned in the webinar, so that the irradiation is quite close to the irradiation in Johannesburg, but Johannesburg or South Africa is quite far away from the equator, and Ethiopia is very close to the equator, and so this gives Ethiopia solar energy, stable solar energy all over the year. So you do not have big fluctuations. Like in Johannesburg, you have a lot of sun in the summer, less sun in the winter, and it's not, so it's more difficult to plan. But in Ethiopia, so it's actually the perfect world or the ideal environment for photovoltaic.
Yeah, definitely. And then you can combine solar energy with other renewable energy sources, like wind power, for example. When you have okay solar conditions and very good wind conditions, you can build a wind power plant as well to kind of use the two sources, and then add up on geothermal energy or biomass or whatever you have.
Or hydropower. So I think a very good opportunity or good solution for Ethiopia is actually the combination of solar and hydropower, because especially so with hydropower you also have a storage option. So usually when you have only solar, so we do not have sun in the night, as we all know, so we have to find a way how to use solar in the night, and batteries are a solution. When we have a combination with hydropower, so it can be cheaper actually, because we have to have less storage.
Yeah, true. Yeah. That's the problem of volatility that you mean, right? The unstable availability of especially solar and wind energy. Because, I mean, you said at night there's no solar energy, and then there's sometimes also cloudy days. So we can't say, okay, we get a fixed amount of solar energy every day. It depends. It is nature, so it depends on how much sun we get. And same for the wind. So there are very windy days, and then there's also days where we have no wind almost, or seasons even. In some regions, it's like there's storms in one part of the year, and then another part of the year it's quite calm, so there's almost no wind.
Yeah, but it's often the argument of a lot of people who say, yeah, we can't fuel the world with renewables, and look at solar and wind, so you can't use them 24/7. But I think it's not a question of renewable energy. I think it's a question of intelligent planning.
Definitely.
So, and we have biomass, and actually what is bringing us the base load? Of course, in Ethiopia we have hydropower, but a lot of countries in the world, they use coal as a source for the base load. And you can operate coal-fired power plants 24/7, and you also can operate biomass power plants 24/7. And so here you have your option for your base load, and then you can add solar, wind, whatever is not available 24/7.
Yeah, it's a bit more like planning effort that you have to do for renewable energy, because it's not like one power source and that powers the whole country. It is looking for the local conditions. Can we use wind here? Can we use solar here? Combining those together, checking. It's two sources already, and then you said base load, so we would have biomass and hydropower on top. So that's 4 different energy sources that we have to monitor and manage and combine together to see that we cover our electricity demand. But I think it wouldn't have been possible before, maybe at the beginning of the Industrial Revolution. But nowadays, look at our computer technology and how easy it is to just do it automatically, all those monitoring and steering of the electricity production. So I think technically it's definitely possible to combine the energy sources, so that is not an argument anymore.
Yeah, or if you are at a small scale level, so then you can say, okay, I use batteries to store the electricity. And especially in Ethiopia, with all those sunny days all over the year, you get every day new electricity, which you can store to use it in the night, if you need it in the night.
That's another question. Do we need, like, that concept of producing electricity at a central point and then distributing it to the whole country? Do we need that? Or could it be a new concept that we just produce electricity where it's needed?
Especially in a country like Ethiopia. I always say if a country has an electricity grid, so then we should work with it and we should find a way to produce electricity on site. Or if this is not possible, then to use the grid to produce it where the sources are available and to transport it.
So for example, if we have like lots of wind power in the north of the country, we produce all the power there, we put it in the grid, distribute it to the rest.
Yes, that's what I mean. In Ethiopia, only 45% of the country is electrified, meaning more than half of the people have no access to the electricity grid. So we need decentral solutions. And so the government already started to go that way. 10% of the Ethiopians are electrified locally with local grids, with solar home systems, with all what is available. Generators,
Yeah, no, that makes sense, definitely. I mean, especially in Ethiopia, where you have Addis Ababa as like the central point where lots of people live, and then a few other urban centers. But the country is so big, and we have so big rural areas where there's only a few thousand people in one area maybe, or just even smaller villages. And there it doesn't make sense to build a whole electricity grid to power those areas. So it does make sense, really.
And what I always say, I mean, so the best electricity is the electricity we do not consume. Because if we save electricity, that's the best way. And the second way is to use the electricity where it is produced, because then we avoid to invest in infrastructure to transport the electricity. If you need electricity for your farm, for your house, and you have the possibility to produce it right where you are, that's the most efficient way, actually.
Yeah, definitely. As last point, maybe, I would like to have a look at Ethiopia. We can't develop a concept now, but we could make like an experiment to think about what Ethiopia has to offer and how we could use that for renewable energy coverage, let's say.
Yeah, I think for me, I have to say that, or we have to say that we started to work in Ethiopia 2 years ago. And I don't know if you, but I was not aware about that unbelievable sources for hydropower. More than 90% of the electricity of the country is produced based on hydropower. And this is only 10% of the possibility. So Ethiopia could produce almost 10 times more electricity based on hydropower. So that's really incredible. I mean, a lot of countries in the world would dream to have the same sources.
Yeah, true. The thing is, should they do it just because it's possible? Because hydropower is the most critical renewable energy source. Because when you build those big dams, it has a huge impact on the nature. Like fish can't flow in the river anymore. They can't like return to where they were born. Fish populations go down. There's a cut through nature. It changes the landscape. People have to relocate. If you look at China with the big dam they built there,
yeah,
it has such a huge impact, and that I wouldn't consider as a clean energy anymore. But if you like, the key is always balance. So if you build hydropower in like a acceptable scale, and then add other energies, that's definitely possible.
Yeah, I think you have to make a proper planning. And so one thing is the environmental impact. The other thing is also availability of water, and you have to make sure that your neighbors also still get water from the rivers which you want to dam. But I think if you have a proper environmental impact study, it's a good way to produce electricity. And I think it could be also very interesting for the country to export electricity based on hydropower, as countries like Mozambique do, or like Laos. Laos actually in Southeast Asia has the same potential or a similar potential. It's much smaller actually than Ethiopia, but also it has a huge hydropower potential, and they produce the electricity and sell it to Thailand. So that's also, I think, interesting to think about for the country, so which ways to go with the hydropower.
Definitely, yeah. But let's look at Ethiopia. We found a very interesting graphic that shows the energy production of hydropower, or actually the water levels, which are the basis for electricity generation from hydropower. And there's a dip in like April, May. So that is the time when it's like dry season, water levels are low. So also less energy can be produced. But at the same time, during that period, the wind power is quite strong. So like it's very windy in, when does it start? Like in October to May in the country.
Yeah.
So it perfectly matches during the time when there's lots of hydropower in rainy season during July and August. We don't have much wind, but we can have energy from hydropower. And then when hydropower energy is low, we can generate lots of wind energy. So that's actually all year round, we get enough energy by just using the two or combining the two sources.
Which is kind of also bringing us back to the development of the country. I mean, Ethiopia already produces 90% of the electricity based on hydropower. But if we see where we are now in the country with the development, and with the ideas that we want to build up local manufacturing, local infrastructure to really bring jobs also to the youth in the country. So we will definitely need more electricity. And then we have to look at wind and at the sun and all the other sources we have. And I think we also have geothermal in Ethiopia.
Yeah, true. Geographically, Ethiopia is very lucky. There's a big rift going across East Africa. So it's like in Kenya, Ethiopia, a few other countries in that area, like along the coast. In Ethiopia, it's especially the Rift Valley. And there's lots of like volcanoes and volcanic activity. That means there's lots of hot water in the near surface of the earth. So geothermal is an energy source that can be used in Ethiopia, which is very rare, hey?
Yeah, it's only a few countries in the world who really have a good potential for geothermal energy, and Ethiopia is definitely one of it.
Yeah.
So, and it's really great. So we have the sun all over the year. We have wind and water, which like fit very good together, and then we have geothermal. So, yeah, I think there's quite a good opportunity for the country to
There is
stay
potential.
with that 90% or even go to 100%.
Yeah, definitely. Because hydropower and geothermal, and also biomass actually, can also be used as storage. They are not limited to real-time electricity production only, but you can save energy for later, which is cool. If you can use lots of wind and solar energy, then you have mostly more energy that you need, and you need a place to save it for later, for periods where you don't have so much wind and sun available. And then in the case of biomass, for example, you produce the biogas and then you can store it as gas, and then when you need power, you process it and you actually burn it to electricity then.
Or even another point, which is even easier, is to store the biomass. You can store the biomass, and then you can either, if you go for any gasification processes, or if you use it in a biogas plant, you store the biomass and then you put it in the anaerobic digestion or in the biogas system when you need to produce the gas. And then it's really cool. So, but I think especially for Ethiopia, the water, it's super interesting, because the thing with biogas is, for biogas production, you need a lot of liquid, and usually you need the manure from cows or pigs. And yeah, when the pigs and cows do not live in stables, it's a bit difficult to collect the manure.
Or like when it's free-range cattle, then
Yeah, then it's a bit difficult, because we always speak about biomass. When you hear biomass, you think on crops and anything what is solid. But if you want to use it in a biogas system, it looks like a liquid. Actually, it looks like manure. It's not that you can put like super solid material in the biogas system and then you will get the biogas. So that it's definitely has to be taken into account.
Okay. No, but in Ethiopia, I think we're still left with the hydropower for storage. That's also like when you already have the plants for that, or you have the dams, it's easy to use that as a storage as well. It's then those pump storage.
Perfect, so actually. I think it's the best way. It's even better than coal, because coal, to produce more electricity with a coal-fired power plant, so you can't do it like switch on from now to the next moment. It takes a while to speed up the process. But with hydropower, that's different actually. So
you open the tap and then it's flowing, and then you get the power
when you need it.
Yeah, and when you have excess electricity, just to explain how it works. So when you have excess electricity, you pump it up the hill, and you kind of fill the water storage. And then when it's needed, you let it down again. So, and the energy is generated through that process, that water flows down, and you're using again the kinetic energy of the water. And the faster the better. You can use energy to pump the water up the hill and up the dam, and then use it or release it later when you need it.
Well, maybe it's a bit difficult to understand if you never saw something like that, but I would guess a lot of you already stored water to use it in the evening or to use it for your fields. So usually when you have a pump, and then you use the pump and you pump water in a vessel, and you have the vessel on a pole, you have it on a higher...
On the roof of your house.
Roof of the house. I would guess that quite some of you saw that already, or used it for either playing or for using the water or for watering the fields. And the whole process is about pumping the water to a higher position and using the kinetic energy or the flow of the water when you need the electricity.
The cool thing again about solar is that we can do that for the big hydropower plants, but we can also do it at home, like Antje said, for field irrigation, for example.
Yes.
And then there is smaller pumps available that run from solar power, so you can use actually solar power not only for big applications but also like small household applications.
That brings me to an interesting point. A lot of people, like in Europe or even in South Africa, when they hear about solar, they think about huge system, utility-sized system. They can't imagine that solar also can be used for a house, or like we just said, the little solar module, what you can carry with you for hiking. There exists a super wide range of possibilities to use photovoltaic or solar power in systems to power your phone, but also to power a whole country, a whole city, your house. So it's really, we have a lot of different options.
Yeah. And we just have to combine them. I think that's the key, we have to know what we're doing, checking possibilities, finding strategy, combining the different sources we have, also considering what do I have in my region, what do I have in my country, do I really need this, or am I just doing it because another country in Europe was doing it? Yes. So evaluating really carefully and then putting it together, because I think we have the tools, we just have to combine them to the master plan.
And they became cheaper and cheaper, so they are definitely compatible.
Yeah. All right. So your job is to develop the plan and develop your country, make use of what you have in front of your door, and develop your own strategy for what you need.
And the good news is that we prepared quite some material for you to learn how to use renewable energies, especially photovoltaic energy, what options you have, how to design, how to install, how to sell. All this you can learn in this training course, actually.
That's good last words. Thank you then.
Thank you.
Thanks for being here, Antje, for joining the podcast and for sharing your view.
Thanks. It was a pleasure.